In this video, I'm just going to be going over a few of the problems on the Why Were the Teacher's Eyes Crossed worksheet, just so you can maybe get a better understanding of how to do these problems. Each one of these differential equations is what we would deem a separable differential equation because you can separate the variables, and so let's go ahead and do that. Separating the variables is treating the dy dx like a fraction of, for example, dy over dx, we can multiply both sides by dx. So you can treat them like a fraction like that, and then you would rewrite the left side as just dy, and then you would rewrite the right side as 3x squared dx. So dy dx is a noun, it's the derivative of y with respect to x, but in situations in which we want to find y, or the solution to the differential equation, we can treat, again, the dy dx like a fraction. So we're going to, like I said, move that dx over to the right side, and then noticing here that we could integrate both sides, we do just that. Okay, and I guess noticing that would mean you've got only y terms or constants on the left side and only x terms and or constants on the right side. So you're not allowed, and I should probably point this out right now so we don't get confused, if by chance you had something along the lines of, let's say, dy dx is equal to x plus y, well, if you went ahead and tried to multiply both sides by dx, yeah, you'd only get a dy on the left-hand side, but then you'd get an x plus y dx on the right side, and then no matter what you try to do, if you distributed the dx, you'd get x dx plus y dx, and you're just not going to be able to move that y or separate, which is the term separation, separable differential equation. You will not be able to separate the y from the x. It's forever attached, and so equations, differential equations in which you have a sum or a difference of the x and the y are not called different or separable differential equations. They are non-separable, and then we handle those differently. Okay, so for the differential equations in which you are able to solve by separating the variables, we do just that. It makes it really convenient, and so this is how it works. On the left-hand side, we're going to integrate with respect to y. And so integrating, and if we put a constant in there, integrating 1 dy, we would just get y. Okay. And on the right-hand side, integrating 3x squared with respect to x, we would get 3x cubed over 3 plus c. And I explained in an earlier video why we don't have a c on the left and a c on the right. So you may want to check that. So I don't want to have to explain that again, bore you to death explaining that same thing again. But nevertheless, we can see here we've got the ability to cancel those 3's, and we just get y is equal to x cubed plus c. Okay, so there's problem number 1 on the Why Were the Teacher's Eyes Crossed worksheet. Okay, let's see, what other one could we do? Well, let's do number 5. I went ahead and multiplied both sides by our dx. Canceling the dx's on the left-hand side gives us dy on the left. And then I'm going to rewrite this denominator here as x to the, well, I'll do this in 2 steps. We'll write 1 over x to the 1 times x to the 1/2. Because everything counts in calculus. You know, you can't just skimp on your steps because you're going to make careless errors. Okay, remembering when we multiply bases together, we have to add their exponents. And so in the denominator we get x to the 1 plus 1/2, and then we still have a dx that I forgot to write down up here. Okay, and then 1 plus 1/2. We still can't skimp on that step. 1 plus 1/2 is 2 halves plus 1/2, and that's 3 halves. Okay, I know these steps are tedious, but nevertheless they are very important. Okay, I've seen errors as bad as 4 plus 1 equals 3, so you can't overlook anything. So anyway, instead of trying to integrate 1 over x to the 3 halves, I'm going to rewrite 1 over x to the 3 halves as x to the negative 3 halves, so we know we can do that. And now we're in a position where we can go ahead and integrate both sides, and we're going to integrate both sides. On the left hand side, we're integrating with respect to y, because we know we don't have any y terms on the left, no y terms on the right, no x terms on the left. And then we're integrating with respect to x on the right hand side. So let's go ahead and cruise on up here. We know that the integral of 1 dy is just y plus some constant, but we'll take care of the constant on the right hand side. And then the integral, or the antiderivative of x to the negative 3 halves is x to the, and be careful here as well, x to the negative 3 halves plus 1, and then again, then that's over negative, I almost forgot about that, over negative 3 halves plus 1. Okay, so we can certainly clean this up a little bit. Negative 3 halves plus 2 halves is negative 1 half. So we have x to the negative 1 half. And now I could divide by negative 1 half here, which I guess I will do that anyway as long as I'm writing that. But when I do these, when I'm in a little bit of more of a hurry, I will save that step and I'll go right to saying out loud to myself, divide by negative 1 half means multiply by negative 2. Okay, so I just flip the fraction over and multiply. So I usually go right, like I said, right from this step to this step. Okay, and again we could clean this up even. We can write this as y equals, let me write a better equal sign here, y equals negative 2 over the square root of x plus c. And yes, you will leave it alone. You will not try to rationalize that denominator unless you absolutely have to. Okay, so leave that alone. Alright, maybe we can try one more. I chose number 20 because after looking at the different problems here, I'm hoping that you, oh, you know what? I do want to do one more. Yeah, I do want to do another one, but no? Hold on. I'm looking for a 1 over x, but I don't see a 1 over x, so I guess we're okay. So now this will be the last one that I do, number 20, unless I get a request to do any other ones. But hopefully you're noticing that when you have an x in your denominator, that you just rewrite that fraction with x in the numerator and just you know, make the exponent a negative number so that you can just use the power rule. So that's the idea, is just rewriting the integrand so that it's a convenient integrand. You can just use the power rule. But I chose number 20 because sometimes the easiest problems can be the ones that throw students off a little bit, and this might have been one of those that did that for you. So let's go ahead, again, multiply both sides by dx, separating the variables, and I'm setting you guys up to be successful in the separation of variables types of problems that you'll see coming up soon. Anyway, on the left hand side we have dy, and on the right hand side we have dx. Really, it's a 1 dy equals 1 dx. And so hopefully you remember that every single time you separate the variables and you want to solve for y, that's what we're trying to do here. Again, we're trying to find the solution to the differential equation. Well, you just integrate 1 dy, and we've been doing that. Integrating 1 dy gives us y. Well, that would mean that when we integrate 1 dx, we would get x. And then don't forget the plus c. And that's it. Y equals x plus c. So maybe that was an easy one for you. It should have been the easiest one, but again, sometimes those easiest ones tend to be the ones that throw us off. So hope that helps, and I will see you in class.